Hello everybody. As you can see, I have opened the walk1 function from our random walk video where we talked about random walks with for loops. And in this video, as you can guess from the title, we're going to be computing an expected distance. And the setup is basically we have a random walk with the for loop. So we know it goes for n total steps. And we can ask, well, how far do we expect to get from the origin? What's the expected distance? So what I'm going to do is I'm going to create a new function. So I'll say new function. I'm going to call it EV under walk for expected value walk. And let's say walk1 because we're using the walk1 function. And we're going to have two arguments as input. So n is going to be the number of steps, so just like in walk1. And the variable x is going to be the number of experiments. And we're going to return an expected value, so I'll call it EV. All right, so like usual, we're going to set up our helper variable, so t equal to 0, so kind of our total is going to start at 0. And the first way I'm going to show you, there's going to be a mistake. So see if you can spot it. I'm going to say for I going from 1 to x, remember x is our number of experiments, t is equal to t plus walk1 of n. So what's the mistake with this? Well, let's take a look and remember, what does walk1 of n return? So walk1 of, let's say, 5. Remember, this is a random walk that takes 5 steps, so it has length 6. So we're saying take 0 and add it to t, add it to walk1 of n, so that would just be adding 0 to all of these. That's not quite what we want to do, right? What we want to do is say, let's look at the last element and see, well, how far away did we get from the origin? So here we got a distance of 1 away. So that's the first mistake. So we really want to do not walk1 of n, but walk1 of n. Now, if I try to do it like this, MATLAB doesn't kind of allow this to happen. I can't do function of something like this. So what I'm going to do instead is I'm going to define another helper variable, v. This is going to be walk1 of n, and then we're going to take t and add v of n, which is the last element of walk1 of n. Now, like I said, this still has a little mistake. Let's see what it is. So I'm going to save this and run it, and then hopefully you can see what the mistake is. So let's say I'm going to call this, so this was EV walk1, so EV underscore walk1. Let's take, I don't know, let's say 10 steps, and let's do 1,000 experiments. Oops, and what did I do wrong? I forgot to set, well, what's EV equal to? So remember, EV is our expected value. So how do we define this? This is t divided by x. So total number divided by x. So remember, we kind of add up all of the last elements and divide by the total number of experiments. So let's run it again. And we can see here, okay, that's pretty close to 0. If we run it again, pretty close to 0. So what's happening now is we're saying, okay, I'm taking 10 steps, and it's basically saying that I stay at the origin. I don't end up kind of far away from the origin. What's going on here is when we're doing a plus v of n, remember this could be positive or negative, and we really want distance. We want to measure absolute value. How far away did you get? So what's happening here is because there's equal probability of going left or right, what ends up happening is you go right, you go left, it gets canceled out. So in the end, we get something very close to 0. So how can we remedy this? We just say absolute value, v of n. Let's save it, and now let's try it. So now let's say I take 20 steps and do 1,000 trials, and we can see I expect to end a distance of 3.5. Let's try it again. 3.5, so I got kind of 2 digits the same in both trials, maybe to try it with 10,000, 3.5. So this is looking like a pretty good estimate. So we can expect on average to be a distance of 3.5 away from the origin. So thank you for watching. In the next video, we're going to talk about a formula for the expected distance, and we're going to kind of plot it against this function and the values that we get. So I'll see you there, and thanks again for watching.